Welcome to this Friday's Tech Drop-In. My name is Ryan Castley, and I'm a solutions architect with Megaport. Today, we're going to be talking about Megaport storage, and then we'll do a quick connectivity demo, show you a file copy to the storage across the internet, and then we will build a private VXC across our Megaport backbone and do a file copy across the VXC and hopefully get a much better performance for speed. All right, so let's go ahead and get started. So Megaport purchased Latitude SH, and Latitude SH provides bare metal, GPU, and CPU as a service, as well as storage. So for the storage, it's object, file, and block storage, high performance flash. Um, can be accessed through, like I said, direct connections across our backbone with a private VXC. It is all flash performance. You get basically a bucket of storage that grows with the usage. So you pay per terabyte for usage only. And most importantly, there are zero egress fees. So we don't hold your storage for ransom. You can access at any time without any additional charges, like you would see with a traditional CSP. So here's an overview of our current storage regions and locations. So in North America, Ashburn, Chicago, Los Angeles, Portland, Toronto. In Europe, I have four: Amsterdam, Frankfurt, London, and Milan. And then in APAC, Australia, and Tokyo. We're always expanding our service offerings. So if there's any region or location that you would love to see our storage to be made available, certainly work with your account teams. And we can work with our engineering teams to prioritize deployments for those areas for you. So here's a quick little diagram of what we're going to be doing. So we'll basically be using a virtual edge as a client on our backbone. And that virtual edge will be running AWS's S3 SDK command line. So all our storage is S3 compatible. So you can use all the same commands that you typically would today for your S3 buckets or S3 compatible storage you're using. So we'll demonstrate that copy from that client over the internet, and then we will build that private VXC and then demonstrate the copy over the private backbone as well. All right, let's go ahead and get started. So here I've logged into our portal. So I'll go ahead and go into services. And here is my my client, my MVE running OpenSense. So this is a great little MVE, great vendor as well. I can load up the AWS S3 SDK and kind of run command lines from it. It's very versatile. We have our internet connection right now at 100 meg. So let's go ahead and add a connection to the MVE to the storage. So we'll go ahead and hit the plus arrow here and choose Megaport storage. Now, the Megaport storage is offered through Latitude, and today it's still a two portal situation. We are working to integrate those portals, so it'll be a single portal, hopefully in the near future. But you can see this message here requires a Latitude account and the storage to be provisioned in the Latitude portal first. So it gives you a link to access the portal. I've already done that, so I'll go ahead and open up the Latitude portal. And here we see projects. So this is basically the starting page. So I'll go ahead and enter my storage project that I created. And here we see Latitude's additional offerings. So bare metal, virtual machines, Kubernetes. We're going to go ahead and go into storage and object storage. And here we can see I've created a bucket already. I got one bucket there, but I'm going to create a new one for this demo. So I'll hit the create bucket link. And I'm going to go with standard performance. And we're very upfront with our pricing, just like everything else. And here are the locations for the standard storage. So I'm going to go ahead and keep it as Ashburn. I'm going to rename it here. V2. I'm not going to enable versioning or object lock. Certainly can do that. Just go ahead and create bucket. All right, and that bucket has been created, sitting at 0 gig. And here we have the endpoint URL, access key, and secret key. So I'm going to go ahead and let's see, copy all of this off. into my own text file. Okay, and looks like I am going to redo this here because it actually has not giving me the secret key. I had previously created a storage with the same name and it's probably using that same key here. So I'm going to create another bucket, standard Ashburn. I'm going to go ahead and call it storage new. Create bucket. And did the same thing. All right. So I'm going to go ahead and go back out, create a fourth bucket in a different location in Toronto. Hopefully that gives us some better luck. Toronto. And same thing. So we have got just a slight issue here. Typically, we'd have that secret key and use that to create the connectivity into our storage location. So I'm going to go ahead and head back out. As with everything, sometimes there are just hiccups. Delete the Toronto. Delete these buckets here. E2. And this new one as well. All right, so I have got the previous storage information here. So we're going to go ahead and use that today. So this is the RMC storage bucket that is currently configured. So that's already done. You basically saw how easy it was to create the bucket, but typically we would get that service key as well. So what I'm going to do is I have that MVE is basically sitting in 165 Halsey Building in Newark, New Jersey. So I'm going to go ahead and log into that device. Just kind of show you the interface here. So this is the dashboard, current interfaces. We have a LAN, a STO for storage, and a WAN. So if you take a look at the actual settings on the MVE, we have a WAN, LAN, and a LAN 2. So this LAN 2 is the STO interface. Basically, we're going to create that storage VXC on LAN 2. So I've got the storage bucket already done. So I'm going to go ahead and go back into the MVE and hit that plus connection again for storage. I've done that already. And my storage is in Ashburn here. So I'm going to select the Ashburn storage location. And we see the latency is 6 milliseconds. So it's nice to know. I'm going to hit next. Just give it a generic name. And I'm going to go ahead and do 1 gig for the VXC. I'm going to choose that LAN 2, NIC 2 interface. Going to leave it as untagged, so no VLAN tag. Give it a month to month. Hit next. So here we get to choose the ASN. So I am going to go ahead and let's see, object storage. Go ahead and go back in here. Portal. Our storage here. I'm going to go ahead and use 6501 and no password. And let's see, I believe that is the way we need to do it here. ASN. Yep, I'm gonna actually use this ASN just to make sure we keep it the same. Next, and add VXC. Reorder. Go ahead and order now. This will deploy that VXC. So basically what it's doing, it's connecting a private VXC, so private VLAN, to the Latitude Z end. And essentially it's just like an MCR. So we're creating a layer 2 connection to an MCR over there, like a cloud router. And what we'll do is we'll establish a BGP connection with that endpoint and get a more specific route from the Latitude object location. And once this is done, this will come up. And before we establish that BGP connection, I'll demonstrate the copy over the internet from the client. All right, so that's established. It's coming up here. And as we can see in here, right now, I don't have any BGP peering or neighbors set up. So if I look at our generic routing, there's no BGP peers set up. We just have the general Megaport internet route, and it's a default route out the internet. I'll go ahead and or actually open up my console connection to the OpenSense, and we will do a file copy. So we have an ISO, 6 gig ISO that we'll go ahead and copy over. So I'll grab the bucket name, just storage. So replace that. And the endpoint. All right, failed. Let's go ahead and redo some of the, reconfigure the endpoints. Go. Test it out. There we go. I'll go ahead and try that again. And there we go. So right now it's using the internet. So you can see the rate we're getting. It's about 13, kind of going up and down. And this is using that 100 meg internet connection. So while that's going, we'll kind of leave that running for a bit. Go ahead and take a look at that storage VXC that we created. So if you look at the details, what you get on that VXC is essentially a /31 provisioned. We have the peer ASN, so that's the core cloud router on the storage side. And here's our customer ASN that we put in there. So that's on our end. That's on the MVE, the client. So we've got our address, we've got the storage remote end address. So we're going to go ahead and use this information to configure the OpenSense MVE, the client, and establish a BGP connection, and then do the file copy again across that private connection. So let me take a quick look at where we're at here. So still going pretty slow. Let's see if I can cancel that. There we go. We're going to go ahead and basically remove that storage copy. Unknown. Probably because we didn't finish the copy. That is not going to delete that. That's to make sure I got the command correct. Yeah. I think this, there we go. There we go, delete that. All right. Go ahead and go back out here, and we're going to go into the OpenSense MVE again. So we're going to go ahead and configure the interface. So we'll add an IP4 address. All right, and that is, grab that information. Should have done that previously. So our address is .45. Go ahead and put it down in this field. There's a /31. Make sure I have no spaces here. Save and apply those changes. Right. Now we'll go ahead and go into the BGP configuration. So here's our AS number 65551, which matches what we put in there. So we're going to go ahead and spin up the remote side. So it's .44. So this is again the storage NNI. We'll configure a neighbor. Go ahead and add a neighbor. Peer IP. Spaces. And we got this peer ASN. Right. There's no other special attributes, passwords that we're using, so a pretty simple BGP setup. Go ahead and save and apply. The nice thing about OpenSense, the BGP is very quick. So we should see that in the routing table pretty quickly. So we'll take a look at that after it just restarts. Diagnostics. So typically you can go to general. And here we see the remote peer, the remote neighbor, .44. So we're receiving this /24 as well as this /26. I believe this is more of a control subnet, and this is the storage destination that we'll use. So basically what we can do is take this address as well. Oops, go into the OpenSense, do a trace route. Nope, not that one. You go back here, grab that. Copy. Go and use .1. We can see the next hop is the remote peer, so we're using that private connection. And .1 probably doesn't exist, so it might time out, but we'll just let it go for one more hop. Yep. All right, so we'll close that out. So we are using the private connection now. And we'll go ahead and grab the copy command again. And actually, we don't have to grab that. We can just do an up arrow. Move and copy. Yeah, great. And here we can see a much faster transfer speed, obviously, because we're using the 1 gig VXC. So the great thing about this is that we can offer, because it is going across our backbone with the private connection, there is a 99.9% uptime because there is no real redundancy in the NNI piece of it. It'll fail over to the internet. So that's how you get your failover to happen. So once that BGP route is taken out of the route table, you'll have your default route and you use the internet to do the file transfer. So here, I think this is pretty close to about 900 meg, if we did the math correctly. 900 megabits per second transfer, so we're just about done. But that really shows you how easy it is to spin up a storage bucket, and as it grows, and basically connect to it privately across the Megaport backbone. So great use cases are, back up your data. You want something for disaster recovery. It's object storage. It's fast performing, flash storage, and very flexible. I believe that is finished. Yep. All right. So I hope you enjoyed this quick little demo of our Megaport storage and our connectivity. And that if you have any other questions, reach out to your account team, and hope to see you online sometime. Thank you very much.